Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. Hello, this is Terry VanNoy. Welcome to my video. Thanks for tuning in, and this is the last video in the series about factoring polynomials. We're going to be taking a look at grouping, how you factor by grouping. But first, take a look at my toll-free telephone number at the top of the screen and my web link there. And that's for people to give me a call to see if I can possibly help them out in their classes. Maybe it's a homeschooling situation. Maybe you just need help preparing for a test. Well, my student clients and families hire me for help. These are personal one-on-one online remote sessions customized to how you learn and when you want to learn. Very flexible schedule. So give me a call if you want more information. The first lesson is free. Now let's take a look at today's lesson. This is factoring polynomials by grouping. Now, the idea is that we do not have a trinomial to try to factor in some of the patterns I've already discussed in previous videos, but the clue is that in most cases, if you have to factor by grouping, of course the directions might tell you to do it that way, but you'll probably have 4 terms, not 3. Now, here's the idea. The key is in arranging the 4 terms in a way that makes it work. There are certain ways of putting these in order where the answer will not be obvious, okay? But most of the times your teacher or the worksheet you're working on will have them in the proper order so far, unless they want to try to trick you or just make it more complex. Now, so what we do is we put these in order of degree. Now, I know that the negative 4x and the positive 3x have the same degree, first degree terms. That's x to the first and x to the first. But here we have x squared and x to the first, and this is a constant. Okay? Basically, the trick is putting the terms in order according to their degree, and then see if you can find a common factor. Now look at x squared minus 4x. Basically just factor those 2 terms. Notice that the only common factor is an x. Okay? Now if I divide an x out of both of those, that leaves me with x minus 4. Again, to double check, you would multiply out again x times x and x times negative 4. Alright, and then I'm going to keep this sign here, and I'm going to look and see what common factor I have with 3x minus 12. Well, in this case, it would be a 3. Okay? And on the inside, that would be x minus 4. Now, here's the key to factoring by grouping. When I split this up, I need to have the exact same binomial here. Okay? Most times it'll be a binomial. So I'm just going to color it in blue, and you'll see that I have x times that binomial and 3 times that same binomial. That binomial has to be exactly the same, the signs and the terms inside and everything. Okay? Now notice how it's here twice. Alright? The key now is to write it once. Alright? If I notice that an x minus 4 is common with both of these parts, I write it down once. So I put down x minus 4, and then I see what's left. On the outside here I have an x. On the outside here I have a plus 3, and that is my other binomial. This x came from here, and this 3 came from here. Alright? Now, it's a lot of arrows, but let me just show you another quick example before we get to some problems. Let's say that we've already taken out the common factors, and the question we need to ask is this binomial the same as that binomial exactly? Okay? If they are, then you write it down only once. Okay? Then it's 3x and positive 4, and that becomes the other binomial. Usually your answers in factoring by grouping is a binomial times a binomial. Alright, again, this 3x comes from that 3x, and this 4 comes from that 4. Alright, so look for a common binomial in that expression. Number 29. just look at the first two terms. Notice how the exponents go down by degree, k to the third, k squared, k to the first, and a constant. All right, so just look at two at a time, 15k to the third and 9k squared. Take out the largest factor. Well, that would be 3k squared. Okay? What's left? 5k and 3. 5k plus 3. All right. Now, if we do this right, we're going to look at the second pair of factors of terms and see if we can find a common factor. I notice that a 2 is a common factor. Actually, let's try a 4. And both these terms are negative, so we're going to factor out a negative 4. And if we do this right, we should get 5k plus 3. Notice this 5k plus 3 binomial is the same as this one, and I only write it down once. 5k plus 3. All right, what's left? I have a 3k squared minus 4. Now, I do need to double check that I can't factor anything else out, and there are no common factors inside that binomial and that binomial. So if I was to multiply that binomial times that binomial, I would have the original problem. Okay, so here we are, factored by groups. All right, number 30. The exponents are in order, so let's take them two terms at a time. I have 42a to the third plus 49a squared. Well, I know there's an a squared common term there. And then look at the numbers, 42 and 49. It looks like 7 can be divided out. So 7a squared is factored out. That leaves me with 6a plus 7. All right, we're going to hope for the best and look at the next group of terms. If I factor out an 8 out of each of those, that would give me 6a plus 7. All right, success, because the 6a plus 7 binomial is the same. All right, so I'm going to write that down once. That's a common factor with that whole expression there. And then I have what's left, 7a squared plus 8. All right, on a piece of paper, I want you to try number 31 and 32, and I'll very quickly, after a short pause, show you the answer, and I'll leave 33 and 34 for you to do on your own. On number 31, notice how 5p minus 2 is the common binomial, and so we write it down once. What's left? 8p squared plus 1. All right, over here, the x minus 2 binomial is the common factor there. And then I write it down once as part of my final answer, x minus 2, and I have 4x squared minus 3. Okay, just a quick note here. Notice that 5p minus 2 doesn't change, but in order to make it work with my factoring pattern in groups, I factor out a 1. That's why it's 8p squared plus 1. All right, don't forget about that. All right, try 33 and 34. And again, thanks for watching this video. All right, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. All right, study hard and take care.